giving up on the head for now. It's too uncomfortable.
Okay.
Okay, so we were saying before we got cut off, we've got our hyperbola. Okay, the vertical asymptote is at x is equal to 2. It's a decreasing function. And if x is 0, y would be negative 1. Okay, and if we carried on, if x was equal to 3, so 2 over 3 minus 2 is 2 over 3 minus 2, 2 over 3 minus 2 is 2 over 1, which is 2. Okay, so that's our function over there. That's the function h of x. Now, the question says, find the limit as x tends to 3 of h of x. Well, if you look at the graph, what's the limit concerned about? Okay, a limit is concerned about where we're heading towards. So as we head towards x is equal to 3 on the curve, the cockroaches think they're going to get to a value of 2. H of 3, it means what is the y value when x is 3, and h of 3 is also equal to 2. Okay. However, we have a problem here at the vertical asymptote. As x heads towards 2, this cockroach is heading down to negative infinity, and this cockroach over here is heading up to positive infinity. So a limit only exists, sorry, just looking at the bird, a limit only exists, it's a great area everyone, if you're heading towards, okay, the same y value. So if you're heading towards different values, okay, what we say here is the limit as x tends to 2 of f of x does not exist. And if you're a live audience, that normally causes a lot of consternation, because the limit does not exist. Apparently it comes from some movie, Mean Girls or something, they said it in that. Okay, so there, at the asymptote, the limit does not exist. So when you...
What do you keep looking at?
Okay, because it's gone. Because with the limit, okay, the limit doesn't exist. So whenever you're going to do sometimes algebraically and you're going to get answers that the limit doesn't exist, what that means, okay, generally on your graphs, is that you've got a vertical asymptote there when the limit doesn't exist. If I said to you, what is h of 2? Well, likewise, h of 2, there's no y value when x is 2. H of 2 does not exist. Okay? Right. Now we're moving on to finding limits algebraically. So generally speaking, this is what you're going to do. The other bit was just a bit of an explanation, because what's the point of not knowing what you're talking about graphically, in my opinion. Okay. So there are going to be 3 main types of finding limits algebraically. The first type, which appropriately we're going to call type 1, if we're going to sub in your x value, the limit value, okay, we'll sub in your x value, and we're going to get a number. And that's simply going to be your answer. So, if I said to you, what is the limit as x tends to 1 of x plus 3? Okay, it's equal to 1 plus 3. We replace x with the 1. We drop the limit notation once we've subbed in. Okay, which is equal to 4. And over here, what is the limit as x tends to negative 3 of x plus 3? It's going to be negative 3 plus 3. Shara, shh, quiet. And negative 3 plus 3 is 0. Okay? That's all you need to know how to do. If you sub in and you get a number, that's your answer. Just for those of you who are curious, what are we doing? Well, we've got the graph y is equal to x plus 3. And what we said is that as x heads towards 1, the y value is heading towards 1 plus 3, which is 4. So the limit as x tends to 1 is 4, sorry. And the limit as x tends to negative, well, here's when x is negative 3. And as x tends towards negative 3, the y value tends towards 0. Okay, that's what's going on graphically, but this is all you need to know. You're just going to be asked to find limits algebraically. So, your first step always, when you're finding a limit, is going to be to sub in the x value, the x value of your limit. Okay, if you get a number, you're done. So in this one, the limit as x tends to negative 1 of x squared plus 5x is going to be negative 1 squared plus 5 times negative 1, which is 1 minus 5, which is negative 4. Tick, done. Give yourself a smiley face. Right? This one over here, if I sub the limit as x tends to 2 of x plus 3 over x plus 1, well, there will be a vertical asymptote, but it's going to be at negative 1. So the limit as x tends to 2 is going to be fine. It's just going to be 2 plus 3, okay, over 2 plus 1, just replace the x's with 2, and I get 5 over 3. And that's your answer. Okay? And then, now, let's think about this one. What is the limit as x tends to 1 of 7? Well, that, whatever that is over there is your function. Just like over here, that was my function, y is equal to x plus 3. Here my function is the graph y is equal to 7. What is the graph of y is equal to 7? Well, it is simply a horizontal line. So the question, what is the limit as x tends to 1 on graph 7, means mathematically, as we head towards an x value of 1, what y value are you heading towards? Well, you're heading towards a y value of 7. So the limit as x tends to 1 of 7 would be 7. Anything, the limit as x tends to negative 2 of 7 would be 7. And in general, the limit as x tends to any x, the limit as x tends to a of k would be equal to k, because this is the graph y is equal to k. So we say that the limit of a constant function is the constant function. Right. Okay, get that all down. Okay, and we are going to have a little break and do the next board. Thank you, Amran.
First, we will be having an interval. This is how you draw a pig. Okay, you ready? One circle. One circle. Oh, never mind. I did it wrong. Now I remember. So you are going to go one circle, one big circle. One circle, one big circle. One circle, one big circle. W, 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 W. Nipple, 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 nipple. E. What? And this is another version of how to draw a pig. One circle, one big circle. One circle, one big circle. One circle, one big circle. W, W, E.
Alright, good day. We are back. Okay. And we're continuing with finding limits algebraically. Okay. The first type we did, you just sub in, so that's always going to be your first step. You sub in your x value. Okay. And you get an answer, and that's your answer. Right? Right. So the next type, type 2, you're going to sub in your x value of your limit, and you get a number, I'm in focus, which is not naught over naught. Okay, not naught over naught. Okay, so if I have this, what is the limit of x tends to 3 of negative 1 over x minus 3? Okay, well you're just going to go right, I drop the limit because I'm subbing it in, so it's negative 1 over 3 minus 3, which is negative 1 over naught. If you get that situation, okay, negative 1 over naught, we say therefore the limit does not exist. So if you sub in, okay, and you get a number over naught, we say the limit doesn't exist. Not that it matters, but what this means is that graph has an asymptote at x is equal to 3. It's going to be an increasing function, so it's going to look like that. And as x heads towards 3, there's no limit. Okay, so that's why we get that answer. Right, so that's type. Okay. If we have this one over here, the limit as x tends to 2 of x squared plus x over x squared minus 4. Got an idea offhand what that looks like, it doesn't matter though. What's your first step always? You sub in your limit value. So you're going to say 2 squared plus, you replace every x with 2, and 2 squared minus 4. So I end up with 4 over naught. As long as that number is not naught over naught, okay, then we can say, therefore, the limit does not exist. Okay? Right. So in general, if you sub in your x value and you get a number which is not over naught, then what do we say? The limit does not exist. Okay? Right, and your third and final type, okay, and this is the most interesting type. If you sub in and you get naught over naught, okay, How much? Okay, you get naught over naught. Okay, that's going to be the interesting type, and that's what 80% of your sums are going to be. That's the most interesting type. It means that there is more work to be done. Okay, generally, what you're going to do is you're going to factorize, cancel, and then sub in. And it's important to remember you can only do this, okay, when finding a limit, okay, not when finding a y value. This process of algebra we're about to do, okay, you can't do it when you're finding a y value, okay, you can only do it when you're finding a limit value. So if I said to you this, change of plans. If I said to you f of x is equal to x squared minus 4 over x minus 2, and I said to you, what is the limit as x tends to 2 of f of x? I'm in focus.
Sorry.
Okay. What is the limit as x tends to 2 of f of x? If f of x is x squared minus 4 over x minus 2. Okay? Better be neat. X squared, I mean, if my handwriting is bad, tell me.
Your
Over
handwriting is
x
bad.
minus 2. Okay? So, here they say, what is the limit as x tends to 2 of f of x? It's going to be the limit as x tends to 2 of x squared minus 4 over x minus 2. Okay, if I sub in now, you don't have to write this down, you get 4 minus 4, which is 0, over 2 minus 2, which is 0. As soon as you get 0 over 0, that's when alarm bells go off. That means we can't actually go find the limit at this point. There's more work to be done. And what is that work normally? Well, as it says in the note, you've got to factorize what you can. So x squared minus 4 factorizes to x minus 2, x plus 2. Okay? All over x minus 2. Now this step which I'm about to do now, this is what you can only do with limits. Okay? You normally lose solution. You cancel the x minus 2. After you've cancelled, now you sub in. So the limit as x tends to 2. Okay, we sub it into x plus 2 and I get 2 plus 2, which is equal to 4. Okay? If I said to you though, what is f of 2? Okay? Well, f of 2, when you're finding a y value or a function value, you can't do this process. F of 2 means what is the y value when x is 2 on curve f? It would be 2 squared minus 4 over 2 minus 2, which is 0 over 0. And 0 divided by 0 is undefined. So therefore, there is no y value at x is equal to 2. Okay. Well, what is going on graphically? Well, graphically, this graph, okay, sorry, I'm just going to have to go over here for this explanation. Okay, this graph of the limit of f of x is equal to x squared minus 4. You don't have to know the graphical part, but just out of interest, over x minus 2. Well, we could rewrite it as, like we did with the limit, okay, and then we could say f of x is equal to x plus 2. We can cancel on condition we state x cannot be 2. So in fact, this graph of x squared minus 4 over x minus 2 is simply the straight line graph of y is equal to x plus 2. Okay. Sorry, f of x is equal to x plus 2, but x cannot be 2. And what we worked out algebraically, over here, we worked out that the limit as x tends to 2 of f of x was in fact equal to 2 plus 2, which is 4. Okay, so as x heads towards 2, the y value heads towards 4. Okay, however, f of 2 does not exist. And for me, that's the most important idea with limits. If we go back here, this idea. Okay, that with a limit, you can cancel and then sub in to get the limit value. You cannot do that though with the y value. Okay, right. And last two examples. So generally, guys, you don't have to worry. Okay, over here. Okay, you don't have to worry about the graphical part of it. Okay, you just got to do the algebra. So if I say what the limit is, x tends to 3 of this thing. Well, if you sub in, you'll get 9 plus 3, which is 12. 12 minus 12 is 0. And 3 minus 3 is 0. As soon as you get 0 over 0, ding, 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 what happens? The alarm bells go off. Means you've got some work to do. What is that work? Well, we factorize. Because it's a limit, I'm allowed to do this. Cancel. And then I can sub in. So I get 3 plus 4, which is 7. So your answer is simply 7. There'll be a hole in the graph at 3, but that doesn't matter. and this one over here, you're going to once again, in fact, if you sub in, you get 0 plus 0 over 0, which is 0 over 0. That's a problem, more work to be done. I haven't found the limit yet, so I've still got to write that notation. And you're going to get 0, limit is x. Now I'm going to factorize, I'm going to take out the x, and I'm going to get x plus 11 over x. The x's cancel. Now I can replace x with 0, and I get 0 plus 11, which is equal to 11. And there's your answer. Right, pause. Okay, very nearly done. Good day. Right. So here is a beautiful summary, a mind map of finding limits algebraically. So, to find a limit, what's our first step always? We sub in the x value of the limit. Okay, then one of three things can happen. First of all, you can just get a number. That number could be 0, it could be any number. It's fine. So if you sub in and you get a number like this one over here, the limit is x tends to -4, you replace x with -4, you get -4 plus 4, which is 0, then you're done. Poof, over. Secondly, after you've subbed in, you could get a number which is not 0 over 0. For example, the limit is x tends to 7 of x minus 7. Replace every x with 7, you get 7 over 7 minus 7, which is 7 over 0. So you end up with a number which is not 0 over 0. Then what's happening there? The limit doesn't exist. You've got a vertical asymptote. The most interesting side is type 3, yay, where you get 0 over 0. What that means is there's more work to be done. What do? We factorize, cancel, and then we sub in the x value. Remember, you can only do that for limits, not when you're finding y values. So, for example, the limit is x tends to 1 of x squared minus 1 over x minus 1. Factorize, that factorizes to that, the x minus 1 is cancelled, and you're left with x plus 1. Sub in x is equal to 1, you get 1 plus 1, which is 2. And then you're done. Okay, so that's your three types. Right, and now what you have to do, I want you to go to your blue textbooks, your mind-born maths, read through the examples in the textbook, page 209 to 211, and then you've got to do all of exercise 6.1 on page 211, the whole thing, and the memo is up on Classroom. It has been an absolute pleasure. Please thank my co-host, I'm going to show you now. Okay, director, please wave to the crowd. Don't act shy. Right, okay. And we will see you in the next video. Bye!